All right. Thank you, Doug. That was fantastic. The soccer ball. I think about how we as IT professionals would take that amazing piece of technology and ruin it. Because first of all, well, it needs an IP address. We need to get an agent on there. We need to manage it now. We need to understand. But look at all the data we can get. We can analyze kicks and look at which students kick better, and make sure that we're passing around the ball equally, and everyone's team players, and analyze them and everything. And then we have to make sure it doesn't have viruses and all that kind of stuff. And oh, by the way, there's 120 quadrillion soccer balls in the world. We have to manage all of these, and on we go. So IT is about taking the fun out of everything. Man, so this is really something. This is my my first IT presentation since Brideforum 2016. So my name is Brian. Hi, and I tweeted back then that I'd be leaving the IT industry, and Gabe and Jack will continue. I mentioned, I think it was on stage earlier, that I spent the last month or so kind of just catching up, reading brianmadden.com and listening to podcasts and everything, kind of seeing what I missed. Not much. The gist is kind of still the same. Those who were at Brideforum or saw like the Brian's Last Day video know that I was growing my retirement beard, like Jon Stewart and Letterman and all that sort of thing. So that was Brideforum last year in 2016 in July. And here's what it got to before I actually had to cut it off. So I don't know. Is Frank in here? I told him last night I'd shout out that my beard was whiter than his. Or you tell him that I mentioned him. I'm sorry? Oh. They're itchy. But anyway, so that's fun. I also mentioned that I took a van, bought a van and drove around the country. That's the van. This is Lake Mead, which is very, very big. I think a lot of us know Lake Mead because we see the Hoover Dam and we see the part of Lake Mead that's around there. But it's, I don't know, like 150 miles circumference. It's really, really large. So this is probably 4 or 5 hours north of the Hoover Dam. And you can just go and camp. Most of the public land that's owned by the federal government, you don't need permits. It doesn't cost anything. You just park your van and hang out. And it's very peaceful. And the only other people who are out there are the types of people who would get a van and just drive to the middle of nowhere and hang out. So, I got to meet a lot of interesting people. So everyone's talking about the Internet of Things, and I guess that's my topic today. And I mentioned earlier that the reason I'm even giving this presentation was because Jed and Simon sort of lured me into it, and I was talking about IoT and that kind of stuff, and I said, oh, IoT, I don't know, and they said, you can say whatever you want about it. So I said, okay. I got two problems with IoT. The first is I think it's dumb. And for instance, when you talk about the Internet of Things, people give you this example. It's like the water bottle that has an LED in it that turns colors and lets you know if you're drinking enough water or not each day. Will flash and pulse and make sure that you're drinking properly. The hairbrush with a sensor that analyzes your hair and how dry or dirty it is and recommends products based on you brushing your hair. This is not, neither of these are made up. The egg container that tells you how many eggs you have in your refrigerator. I want to be very clear that I am not in any way making this up, and has a companion app, so when you're at the grocery store, you can see how many eggs you have at home, which beats actually calling your spouse and asking them, because if you have this device, you clearly don't have a spouse. So it's the light bulb that you can turn on and off via Twitter. It's the toaster which I'm still 100% not clear on this one, because I don't know what this. I've been using toasters. I'm 40 now. I've been using toasters for, let's say, 38 years, and I'm unclear on what features my toaster is lacking. But this one is a more expensive version of my toaster and has more. There's more buttons. There's a screen. It's got all the elements. The dash button. I mean, this is a button so that when you run out of any product, laundry detergent, because right now, if I'm doing laundry, and I'm out of detergent, I'm running low, I have to be like, oh, get this out, Amazon, Tide, one click, send. Yeah, those days are over, my friend. For $5, you can just click this button and have that laundry detergent sent right to you. These buttons are so well, I don't know. I guess the buttons, I'm like, when is the situation so dire that, you can't use your phone and you need that product immediately? I mean, I poo-poo this, but there's one occasion maybe when that, okay, if it comes with the 3M strip to go next to it, maybe I can understand that. Although it's like pulling that thread. Once you do this, you start to realize, okay, the dash button's like, I showed you this picture. You didn't see the bottom of the picture though. If I scroll down, you can really get used to those buttons. I mean, can you imagine like, oh, I've fallen. I can't reach my Doritos. And you can program it so it can use like same-day delivery and drone and all that kind of stuff. So not I guess not all IoT is dumb, because clearly, it's got its use cases. But anyway, when I think of IoT, I have a hard time tying it back to IT and what we do as end user computing professionals. The other problem I have with the IoT is I'd rather stab my eye out, because if first of all, you think about these numbers, and there's numbers that were presented here earlier today. IoT devices will outnumber the world's population this year. Gartner says 8.4 billion connected things will be in use by 2017, up 31%. Popular Internet of Things forecast 50 billion by 2020. Number of connected devices, 125 billion by 2030. And all of these, I mean, I can't even deal with human users. And there's only 7 billion of those. And I can't imagine now, just like I'm thinking, because that's what I'm thinking, everything that happens as an IT professional, I'm thinking, how does this affect me? Like, when I hear we're going to have a merger, okay, now how many more users do I have to, this new application, how many more applications do I have to support, what do I have to do? So now when I hear all these devices, like, oh, that's cool. I already dealt with laptops and phones and tablets, so I'm already dealing with 3x the number of devices times users I have. So now I hear it's going to be, 50 devices per user. I'm like, that's great. So my budget's increased by 50, or, how exactly does that work? And then don't even get me started on the security in IoT. About IoT security, there's a saying, what about IoT security? Well, the S in IoT stands for security. Wait for it. I can't take credit for that joke. But so that's again, when you hear IoT, not only is there going to be 125 quadrillion devices that are doing it, from connected cars, healthcare, to uranium enrichment facilities, 5 IoT security hacking instances to take note of, 5 nightmarish attacks that show the risks of IoT security. IoT security incidents rampant and costly. Half U.S. companies hit by IoT security breaches, says survey. So again, all of this to me, when I'm thinking about IoT, my reaction is, no thank you. I'm good, thanks. We have all the devices that we want. So I ignored IoT, and I did pinball instead. That is the correct answer. And so in the past, 18 months or so, I would go to pinball conferences, which is a thing. I mean, you shouldn't be surprised. By now, you know that every sort of subculture and community has its own events and gatherings and everything. So I got into building custom pinball machines along with Gabe Knuth, and updating software on pinball machines, building from scratch, retheming them, and we started building our own, and then eventually ended up writing our own open source pinball framework that other people can use, because there's a lot of people building pinball machines, but they're all writing everything from scratch, and it was reinventing the wheel again and again. And so this framework we started creating. It's free, it's open source, it's used all over the world, it's hardware agnostic. There's lots of pinball machines that are running it. It's very cool. It's called the Mission Pinball Framework, and it's just a free open source project. There's no money. The entire GDP of pinball is like $5 million. I mean, it's not. You're not making money. It's a hobby. It's a hobby. But my point is, I got really into pinball, and wasn't thinking as much about IT and Internet of Things and all that kind of stuff, until I started putting some pinball machines on location. And on location means like when you have a pinball machine, like if there's a pinball machine at the Starbucks or whatever. That's a hypothetical. No Starbucks has pinball machines. But the thing is, pinball is not popular at all, really. So a couple quarters per game. A pinball machine can make, I don't know, $10 a week, $20 a week. And if it just sat there and you didn't have to touch it, and you could come in once a month and collect $50 out of it, that's fine. But they're mechanical things that break, and they're very complex. And the problem is, pinball machines go back to the 1940s, and even the newest, most modern ones don't really have a phone home reporting capability. So, if you have a machine, maybe you check it once a week, and if that machine breaks the minute you walk out, it's not earning that entire week, and you don't know it. Or if it is earning and it's working fine, you drive back to check on it, and you wasted that trip, and you just burned all your profit in the machine going to check on it. So Gabe and I put together this little device. This is, again, it's an open source, just created the design for this and figured it out, and then put the code and the plans out there. That it's a little device that goes inside the pinball machine, and basically it has Wi-Fi, connects to the bar's Wi-Fi, and just tells us, is the machine on? And every time a quarter goes in and it registers a quarter, it just puts that up in the cloud. And then that way you can know if the machine is taking quarters, I mean, it's working. Even if the machine's broken, as long as people keep on putting money in it, it's working. And then also, just if the machine's not taking quarters, even if it's on, something is wrong, which could be maybe someone put a do not play sign in front of it. Maybe the Bud Light rep came in and put a banner about Bud Bowl in front of the machine that's blocking it. You don't know what the reason is. But basically, if it's making money, it's fine. We don't have to visit it. And as soon as it stops making money, we go. And that's really great, because again, we can make a device that costs a couple dollars, and it just sort of does this thing quietly, and it works. And then it makes it very easier for people who have pinball machines, and this can work for old arcade machines and Pac-Man and any of these kinds of things that are out there. It's really cool. And when that happened, I was telling Jed and Simon about that, and they're like, "Well, that's IoT, And I'm like, "Oh, okay." Okay, I get it. So IoT can be useful. You just have to look at it from the customer standpoint, whatever, instead of the IT standpoint where we want to say no for everything. So anyway, this talk today, it's about IoT and EUC, so Internet of Things, and specifically how it ties back to end-user computing. And for me, there's two ways to think about this. The first is as an IT pro, so that's like from our standpoint, how do we think about IoT and that? And then the second is from the user standpoint. So I want to go through each of these kind of one by one. From us is basically how do we manage all this? Because at the end of the day, that's what IT is. We hear these things are going to come, and we have to figure out how to manage it. From the user standpoint, they're like, oh. Toys. This is so exciting that we can have all these great new things to play with, such as the egg counting things and that sort of thing. So obviously, two very different perspectives. And frankly, this is no different than anything else. Like replace IoT with iPhone or anything else. The IT standpoint is how do we manage this, and the user standpoint is exciting new toys that we have. So let's look at each of those one by one. So let's start with us, because, IT. So taking a step back, like what is an IoT? Like when we actually talk about Internet of Things, and there's always things we have to manage, like what does that mean really? And there's actually two different types of devices out there, or two different classes of devices that could fall under the IoT umbrella. The first one they call three-tier devices, and I'll show you this in a second. The point I'm trying to show here is these things are teeny, 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 tiny. Like that little, these things could be like a size of a dime or smaller, very, very small. You can buy, like the chips cost in the tens of cents. And if you're designing a device, you're going to make millions of them, you can make a device for under $1 that has this kind of technology. These are sort of development boards you can buy to play with, and even these boards cost only $3 or $4. And there's a bunch of different boards and different models and different microcontrollers and stuff. But they're very, very, very small. They're very, very, very cheap. So an example of these that you might be more familiar with is like these internet-controlled light bulbs, or these color-controlled light bulbs. So they have this type of circuit inside them. Adding that circuitry into the light bulb, adds 25 cents to the cost of the light bulb, something like that. Now, those circuits are so small, they're very, very cheap, they're low power, but they're not that smart. So in order to do everything, they need to talk to a hub. So in this case, if you use a Philips Hue, I'm calling it the light bulb hub. And they're going to talk via some kind of, it's typically wireless, but it's a protocol like, there's a bunch of names, Z-Wave or Zigbee are both wireless protocols. These are even more simple than Bluetooth. So you can think of like, Wi-Fi requires TCP/IP and IP addresses and, all that kind of stuff. Bluetooth is a little bit simpler. These things are talking even simpler than Bluetooth. Some vendors have proprietary ones. The Z-Wave and Zigbee are both open standards. But the point is that each of these light bulbs doesn't have an IP address. It's not something that's too smart. It's just talking to that hub. And then the hub has the IP address and talks to the internet and does all that kind of stuff. So they call it three-tier, just like three-tier computing. You've got kind of like the really dumb device. The intelligence is on the hub, and then the hub is acting as the gateway, which is going out to the internet or everything else that you're doing. If you buy, for example, the Philips Hue, you get the light bulbs and the Philips Hue hub. They come together. There's also, if you want to use Zigbee or Z-Wave or one of these others, there's more generic ones. Mozilla actually announced just yesterday an open source software package to build your own hub. And this then will talk via Bluetooth and Zigbee and Z-Wave and everything. It goes on a Raspberry Pi, which is an open source computer you can buy for about $35. And then you can put the software on there for free and build your own hub. But again, the point is, this is all the three-tiered, like really, really cheap and dumb devices to a smarter hub up to the internet. So that's the first type of IoT, is this three-tier. The second one has the name that they call Human Interface IoT. That's really what it's called. Human Interface IoT is where the device is still a thing, if you want to call it that, but it has a little bit more smarts to it. So again, I'm showing a Raspberry Pi here. The Raspberry Pi, that costs about $30 or $35. It's still very small. It's not much bigger than a pack of cigarettes. However, it's got a full ARM processor. Oh, you've got one right there. Look at that. It fits inside here. This is the a thin client one, but it's inside this box. It costs like $35, but it's got SD card. You can add an SD card for storage. It's got a couple gigs of RAM. It's got a multi-core processor. It's got GPU, keyboard. It's got Wi-Fi. It's got Bluetooth, and so it's very powerful. You can run on here. You can run Linux. You can run. There's versions of Windows. You can run Android. There's a whole bunch of different things you can do with this. So this thing can get online. This thing can be a computer. It can be a thin client. Now, it's still small. It still costs, $30, $35. But they call it human interface because you actually, as a human, have a way to interface to this thing. You can remote to it. You can shell to it. You can add a Bluetooth keyboard. You can use a mouse. You can plug in a display. This thing's got HDMI. So again, it sort of depends on the level of thing you need. If it's a super, super cheap, very dumb thing like a light bulb, you probably have one of the very cheap ones that goes through the gateway. If it's a little bit bigger device, a pinball machine, like one of these could run all the code for a pinball machine. So this $35 device is not the device that we drop into pinball machines to see if they're online. We can do that with the $1 device. But if it's more powerful to actually run the game or whatever, We do that with this human interface one. And like I said, these human interfaces, these are full computers. It's ARM or x86. It's running Linux or Windows or Android or Tizen, something like that, more sort of like real operating system. So again, when I talk about IoT, there's two real different classes of IoT devices. So again, so what does that mean for us as IT professionals who are in the end user computing space? Well, the sort of good news, if you go back to these two examples, the sort of the 3-tier with the super dumb devices or the more expensive, you know, our job is to manage this stuff, right? Well, the nice thing with that 3-tier, we're managing that hub right there. So, or on this human interface, that's where we're managing. So all of the management vendors, if you look at EMM vendors or MDM vendors or the way, if you're going to manage IoT devices, that means that we're managing the part that has some intelligence that can run an agent or run our software or that we are able to talk to and access, you know, via the internet and all those kinds of things. The reason I mention this is so in this case, we're not managing the light bulbs. Now, we may see that, okay, I'm connecting to this many hubs and that has this many downstream light bulbs. But the good news is when someone says, you know, there's going to be 125 billion IoT devices in the world, that doesn't mean that we have to manage all 125 billion, because a lot of them are going to be the very small, very dumb devices that will kind of aggregate, and we're only managing, you know, the sort of the higher level, these hubs there. And that's nice because that makes this whole thing a lot more palatable for us. It doesn't become too much different than what we're doing now with phones and tablets and laptops and all that kind of thing. Now, of course, the examples I gave before when I said IoT was dumb, I mean, it's, you know, IoT is not really dumb. Well, it doesn't matter if I think it's dumb or not. You know, it's happening. My examples were examples of like maybe dumb products, but that's not like that doesn't apply to us in the EUC world, right? Like when people say, okay, we have to manage devices, it's not. We're not managing toasters at our company. You know, we're managing the whatever it is our company does. It's the, you know, all the controls on the industrial robots and their sensors and everything, or the, you know, the network of Coke machines and vending machines, or the, you know, farming feeders, or the elevators, or whatever that's going to be. These are all the things that our businesses are managing, and these are things that maybe before didn't necessarily have IP addresses in them, and now they do. And so, I mean, you know, going back to the vending machine examples, that's a great example. You know, all new vending machines now have IP addresses. And they've got little antennas on top, or they go into the Wi-Fi. And it's not just for doing credit card processing, but it's for maintenance reports. It's for letting know what products are being sold. It's actually interesting because you think, oh, it's great. They can know when they're running low on certain inventories and what they need to reload. That's fantastic. But the real data comes from, of course, like how Doug was talking about analyzing shopping habits. They know who's buying Coke versus Coke Zero versus this. They can tie it to outside temperature, and they can do dynamic pricing, and they can do all sorts of things with sort of analytics about all the data that they get with that. So, and this, again, this is something that 5 years ago was not a thing, but now if you work at a company and you're the IT pro at a company who has a bunch of vending machines, all those vending machines have IP addresses, and they're reporting back somewhere, and that sort of starts to become part of your job. But here's what's interesting. So far, IoT, it's not really useful for IT, right? Like the Internet of Things, I gave all those examples with like the pig feeders and the Coke machines and stuff. But for us, in IT, it kind of doesn't matter because we're still dealing with Windows laptops and tablets and Windows sessions and profiles and phones and all that kind of stuff. So that side of the business that runs the Coke machines is not the IT department. That's used by something called OT. And OT stands for operational tech. And so operational tech, this is all the, you know, industrial machines, scientific equipment, robotic welders, you know, your oil and gas rigs, Coke machines, elevators, airplanes, thermostats. It's all those sort of things that are going to be out there and have all the sensors that we're going to start collecting data on. Now, what's interesting about this operational tech, I mean, it's complex. When I say it's not IT, I'm not trying to discredit it or anything. I mean, they have their own complex infrastructure and networks and meshes and security and all that kind of stuff. But it's something that exists sort of wholly separate from IT. And that's that's how all these devices sort of exist in the world now. So it's interesting because OT and IT, they care about different things, right? And the OT, the operational tech, they care about the business. Whereas IT, which is more of us, we care about the infrastructure. So OT cares about, are the trees healthy, right? I've got a sensor in there that's going to check whatever it is, growth, tree happiness, water flow, sunshine. OT cares, are the trees healthy? IT cares, is the device healthy? Can I ping the device that's checking the tree? OT cares, when will the bearings need to be replaced in this industrial device? IT cares about when will the batteries need to be replaced in this device. OT cares about when will the machine need to be refilled. IT cares about when will the firmware need to be updated. So these two things, they're related, but they're two very different things. Now, eventually, the things that make up the thing are going to get more complex. That sounds really weird. The things that make up the thing. So all of those things out there that make up the IoT, I talked about how they're just very dumb, 3-tier, maybe in a light bulb and that kind of stuff. But of course, everything gets more powerful, more complex. So, eventually these things are going to have, if they don't already, firmware in them that will need to be updated. They might have network access. We talked about how 5G is going to sort of change everything in terms of lower cost devices being able to access internet directly. So we are going to see a continuing evolution of the complexity, which again, that's the way it works in the world of IT. So it will continue to grow and get more complex, which is going to mean that all of those things are going to need more management. So even as I look today and say we can separate IT and OT, that might be more of a worldview of how things are today and how we start to approach the Internet of Things. But those are certainly going to start converging. And this is where we come in. This is where the IT department comes in. And why? I mean, first of all, the operational tech, they're not used to this level of administration. I mean, when you start saying that, if there's a company that owns all the vending machines and they're used to paying someone in a truck to go around and take out the quarters and refill the, grease the machines and refill the products, and now all of a sudden they've got, 10,000 devices to manage, that's not a core competency that they have, but that is a core competency that we in IT have. This is exactly what we've been doing for all the years. And this one doesn't run Windows, so all the better. So IT, this is not like an IT versus OT kind of thing. We're definitely going to be part of the conversation moving forward. So again, you can sort of look at OT, the business side, versus IT, the infrastructure side. The business side, they're still going to pick the devices. Like no one in IT is telling them what kind of candy machine to buy. They're going to pick that, but we're going to manage it. So and we might work with them in terms of standards and protocols and how that sort of stuff goes. The business is still going to analyze the data, and we're going to manage the data. We're going to house the data. The example earlier from the temperature sensor, that the thermostat that updates its status once every second, and how many of those do, now we got 86,000 readings per day. That's 86,000 database entries times how many temperature sensors. That's a lot of data that needs to go somewhere. IT might not necessarily be responsible for thinking about what kind of curtains can we buy to minimize our costs, but IT can make sure we have a data warehouse that can house all these readings and we can deliver it to them quickly and they can do the right queries and it has a reliability and all that kind of stuff. But here's what's interesting with this. This isn't that different than how IT works with the business today. I mean, at the end of the day, probably 99% of the applications that we support, we don't really have anything to do with. Like, we don't 100% actually understand even what they do. So, what are we good for? Antivirus and, Word. And pretty much everything other than that, they pick it. They tell us. We might tell them, well, it's got to be, compatible with multi-user. We might tell them these requirements, which they may or may not follow. Other departments might go rogue and do that. I mean, we know this. This is our life as an IT professional, specifically one who's supporting the end-user computing space. So from the IoT standpoint, it's actually not that scary. Because again, they're going to pick their devices. They're going to start reporting up on data. We'll manage the devices. We'll make sure we can push out the firmware and talk to them, and the network connections are good. We'll make sure we can keep their data warm and clean. And they will be responsible for the business side of everything. By the way, moving forward, we're going to have IT-OT convergence. And this is actually a thing. This is not my prediction. Like I'm telling you, this is lots of people have been talking about this. Gabe and Jack have written about it. Gartner actually had a paper about this from like 2011 about OT and IT convergence. And a lot of times when people talk about the OT and IT convergence, it gets into like big data and machine learning and all this kind of stuff, which is all fine, but I think that kind of mucks up the conversation because you could apply that now to everything. I mean, even a regular XenApp farm now has big data and machine learning to analyze your clicks and are you a threat and when you last authenticated. That's happening all throughout IT again. So again, here is no different, but the general idea that the business is going to pick more devices that are smarter that we have to manage, again, that's no different than them picking applications and databases and services that they use that we support anyway. So in this future, we see IT can manage the device, as we always did. IT can manage the data, as we always did. OT, the business, they'll have to tell us what they need and what to look for and that sort of thing. And IT can help make them smart. And that's, at the end of the day, I mean, what we as IT, fundamentally we exist to serve the business and help them, conduct business in a more efficient and better ways. And that's what we're doing here. So it's really no different in the IoT world as it is with any other kind of device world or anything else. Now, do we have the resources to do this? Does IT have the resources to do this? The good news is, yay cloud. Many of these, or maybe even all of these IoT devices have the ability to go to these gateways, and then from there it sends the data to some aggregation point, to some database, to some analytics engine. Just like any cloud conversation, you can run the stuff in-house, you can run the stuff in public cloud, you can store it in-house and run analytics as a service from public cloud. If you look at the cloud providers, both Microsoft and AWS have many, many services each around IoT intelligence and data collection and learning and processing and event notifications and all of this kind of thing. So again, it's, this is not that different than the evolution we've been doing all along. I think because IoT is sort of the first new technology to come along post-cloud, all of these IoTs and all our infrastructures are all cloud native. So it's a lot easier. It's not like when we take, XenApp and put it in the cloud. We have, like in the early days, we had to basically recreate our on-premises XenApp and put it in the cloud because XenApp came out before the cloud was a thing. But now this stuff comes out post-cloud, and it all pretty much works in a cloud-native way. So where do you begin as an EUC IT pro? The first is just keep it simple. So is the device on? What's the temperature? If it's a temperature sensor, what's the just start with easier things. You can always start collecting data. Maybe you can do some more basic alerts on the temperature is too high or this machine is off when it should be on. That's the more simple stuff. But don't try to get all AI about it right off the bat. And so when I say that, I'm saying, again, temperature sensor in this room. We can say this room should never go lower than 50 degrees because things will freeze, and never go higher than 100 degrees because things will melt. That's very simple to say, is this room always between 50 and 100 degrees? If not, trigger a systrack alert or whatever and ping me and let me know so I can come and check it out. That's very, very easy. Now, the AI-ness of this is getting into, well, like look at the temperature and the sunshine hours and the weather report and try to, automatically control our windows to make things more efficient, and then look at how many people are in there and analyze, I can preload the temperature by 0.2 degrees per person coming into this room per minute, per butt seat minute, and save 12.4% across the whole builds, which is probably very possible. But that's like, that's when you're like AIing some shit up. All very possible. But like kind of very different than like our job as EUC people. We're pretty much, give me a high number and a low number and I'll color a light bulb red and page you. And so I think there is an opportunity for us to do the simpler stuff now, and then we get into the AI thing as things go on. Again, separate the device from the data. So just because we have an IoT device or a whole series of devices we have to manage, we can talk to them, we can firmware update them, but that doesn't mean we have to collect reams and reams of data. I mean, just because your thermostat can report to you per second what the temperature is, doesn't mean we really need to know per second what the temperature is. So, all kind of common sense stuff that's the same as what we've been doing in IT for a long time. So that was IoT from the context of the IT professional. That was how we think of IoT. I said on the other side of things, we have the user, what the user thinks of IoT. And it's interesting because, so first of all, the EU in EUC, I mean, EUC is end user computing, right? So the EU part is all about the end user. It's about how the human interacts with the computing. Or in other words, it's the IT to human bridge. And this may be a little bit of grandstanding, like to make our segment of IT seem really, really cool. But I mean, if you think about it, I mean, EUC, this is where the rubber meets the road. Like, this is where the action happens. All the cloud, all the servers, all the data center, all the backend, $3 trillion total addressable market or whatever it is. At some point, a human meatbag needs to interact with the digital ones and zeros, and that's what EUC is. And for a long time, that was a desktop computer. And many of us started our careers working with desktops, and then laptops came out. And that was just an evolution of that. There's some things that changed to how now users could work on the road, and they could work on airplanes, and they could work at home, and there's all these different use cases it enabled. It also changed security, because there was no encryption on hard drives when they were locked in a building, and now we have to worry about that kind of stuff, and two-factor authentication, and VPNs, and all these things. But we got new features, and we had more work to do. And then, you can go to, phones came out, and now we started talking about the whole conversation again, and then tablets came out. So I think, in 2018, if I say, what is EUC, is this. This is what we're managing. Very few of us are only in the desktops and laptops Windows world. We're kind of all dealing with, or our departments are now also dealing with, MDM and EMM and phones and tablets and all these things, in addition to all these types of devices. So over 20 years, desktop, laptop, phone, tablet, that's not going to stop. The definition of EUC isn't frozen in time right now in 2018 at this thing. What's next? Wearables, maybe. That's a thing. And there's maybe apps for them. There's maybe things that to manage and things about security and all that kind of stuff. How about the speakers we talk to? So that's a way that, if we define EUC as the way that humans interact with the technology that we provide, people talking to their computers is certainly part of that conversation. Intel just yesterday announced it's just a prototype of a set of glasses where it projects, it's a laser beam that projects off the glass and into your eyeball. And it's just a screen that shows data. So it's not a Google Glass where there's no speakers, there's no camera, there's no button to push. It's just putting things in front of you, directions. I want to have a camera so everyone who I see, they can face scan them and tell me who they were and where I last saw them and what company they work for. Pull up their LinkedIn profile right as I walk around with them. Do you ever watch Veep? What Tony Hale would do to Julia Louis-Dreyfus when he's always whispering to her over the shoulder who this is and where you know them and his kids at Harvard, that kind of stuff. So these devices are coming out, and to me, these are as much part of EUC as a phone and tablet and laptop and any of that kind of stuff. And a lot of stuff would broadly defined fall into that IoT category. It's interesting, though, because the reason I say that this makes sense is, at the end of the day, EUC, it's about the apps. And I've written this so many times, where we talk about what is a desktop. It's a collection and collation point for your security context and your applications and your user interface and all that kind of stuff. Everything in the EUC world is about the apps. And you can look at this, people talk about, dining versus snacking. I think Templeton talked about that back in the day. You work on a laptop and use it for content creation, and on a phone, You can create, there can be light content creation, but you're really just more viewing stuff on the phone versus actually creating content on the phone. But at the end of the day, if you boil it down, it is, there's application. Your app is email. Your app is communication. You know, tell Nabil that I'll be late. Tell Nabil this idea is good. Tell, you know, this, yes, no to that. Here's my slide. Here's a picture. This is approved. What were the numbers last quarter? And these apps have different formats, and we know now that we can create different apps. Like, there's very few of us are using remote HDX connections on our phones, right? Because most of our business apps have small screen touch-based interfaces. So I don't use like the web browser and browse to chase.com for my credit card with a desktop interface on my iPhone. I use the Chase app, which is made for my thumb and all that kind of stuff. So the apps themselves have evolved to support the proper user interface. And again, it wasn't like that when the phone first came out. It wasn't like that when tablets first came out. We tried to remote to everything. But over time, the apps evolved to that proper interface. And frankly, that's exactly what we're going to see with these IoT-type devices. I mean, Alexa for Business is a great example of this. And I don't know how many of you played with Alexa. They call it skills, which are like plugins. It's apps for Alexa. And like all app stores, 99% of them are garbage. But there's some gems in there. And you can get ones that can plug into your Outlook calendar and your GoToMeeting and your Salesforce and your numbers and TurboTax and all that kind of stuff. And again, just like you might have like QuickBooks for desktops that has full report generation and you can do all transactions and everything. You might have QuickBooks on your phone, which you use to capture receipts and start and stop tracking mileage and maybe view like reports and that kind of thing. Why not QuickBooks for Alexa that you can just talk to and say, how many, like, what was our sales last quarter? How many, utilization do we have? That sort of thing. And that's a human that's a natural interface that makes a lot of sense. I had one that was a tech target for a long time. It was called Mariah. When I'm like, hey Mariah, what's our numbers this month? Or how many, like, what time do I have to be in tomorrow? But you think about that. Every question I asked her was a question that I could have found on my own. That's how you know that your coworkers just love working with you. But it's easier to say, where are we going tomorrow again? What's the address? And that's the interface. So again, this is just using as a for instance. This is just using the Alexa as an example. But Amazon's Alexa for Business, it ties into your meeting schedules and your calendar and all of those things. And you can say, start the meeting, and it knows what calendar you have and what that means and how to dial in and how to connect and how to do those kinds of things. And you can look at these business skills again, plugging into QuickBooks and Salesforce and all those different kinds of things. So again, this is one sort of example. But to me, I believe the IoT from the user standpoint will be the next logical evolution of the user interface. It is what EUC is as we move beyond phones into wearables into voice interface and all these other things. Now, in order to make this work, this is getting into machine learning and artificial intelligence, natural language processing, which natural language processing, it's easy for a computer to transcribe the words that you say to it, but it's harder for it to pull out context. When I say, start my meeting, they need to know what exactly, who you are, what meeting is, what that all means, and how it comes together. Now, again, this is all sort of cloud-based, and Microsoft and Amazon and others are working on this sort of thing. So there's a lot of work that's going to have to happen to make this all come together. But to me, this is absolutely the direction that everything is going. Now, the security is still a big question mark, especially when we bring this into the business standpoint. Do we use voice print identification? Like, how does my Echo, my Amazon Alexa, know that it's me versus my friend? Do you identify by voice print? That seems like it's really easy to recording and play back. Is it proximity based, like your phone has to be there and the voice has to match? Do you have an audio pin? Like, Alexa, what is my, what are the numbers this month? Password 1, 2, 3, 4. That seems ridiculous, right? We don't know. Like, this is a big problem. Like, we don't really know what to do about this at the exact moment. But again, man, look when phones first came out. I mean, look when laptops first came out. I think laptops were invented before VPNs, right? I mean, so I think that we will get there as an industry, but it's something that we are going to have to sort of figure out. The other thing about this, which is kind of interesting, is remember Fuit? Yeah. So this is I talked about. I gave presentations probably 5 or 6 or 7 years ago about the consumerization of IT. This is where, you know, when phones first came out, the IT department could say no iPhones, and you know, we only have BlackBerries. So fine, you have a BlackBerry, and you also have an iPhone, and then you put, you know, digital rights management on your BlackBerry to prevent you from emailing attachments out, and so you know, pull up your iPhone app and you like Yahoo Mail it to yourself or whatever the thing. There's always these ways to go around these kinds of things. And it was talked about the consumerization of IT. I called it Fuit because my joke at the time was Fuit is Latin for he, she, or it was. Like IT was in charge of the users, but they're not anymore. Fuit, though, the real reason I chose that word is because Fuit is spelled F-U-I-T. And it doesn't matter. I mean, look at, no matter, this is from 2011, we started talking about this. Look at what happened with Strava in the news. Did you see this a few days ago? Like, they identified U.S. secret drone bases. Strava is an application that you run or bike with it, and it plots your route. And here's what's crazy. It plots your route and shares your route on social media, but you can disable that. I mean, because of course, if you're in the military and you're running around a secret base, turn off sharing. I mean, you know, no shit. They did. But you know the problem is? But Strava, they anonymize, they show heat maps to show what running routes are popular. It's anonymized. It's not shared. It's not you. I'm not sharing your route. I'm not saying that you run like this. It's just anonymized heat maps to show where popular running routes were. So Strava, every single member of the military who's using this did the proper thing, followed the directives, and turned off, you know, the sharing and social integration, all that kind of stuff. But Strava, hey, we anonymized it. But look at in the middle of, you know, some country where there's no actual drone base, you know, allegedly. Look at the drone base shaped outline of the running route that is popular in this part of the world. And again, the users were doing the right thing. And people were like, oh, they're going to block Strava. I mean, it's whack-a-mole. They block Strava, next is this, next is this, next, you know. So as we get to IoT, you know, it's going to be the next thing like, oh, my gosh, the hairbrush that everyone is using is now determined that, you know, you're poisoning the water in this city. And it's going to be, oh, no hairbrushes, and now it's next time, oh, we got a comb instead, or whatever it's going to be. So as all the, you know, the IoT thing, you know, there is a lot of power that it can have as the evolution of the end-user computing environment, but it's absolutely going to be the same Fuit that we have been dealing with over all these years with, you know, the tablets and phones and everything like that. Which is again, you know, as one way to deal with this is to look at the device management frameworks we have, whether it's, you know, EMM or MDM type stuff, and trying to enroll these things. And there's a lot that can be done, but my point is we have to actively think about this and do it. So anyway, that's all I got. That's the short version of IoT and EUC, and you know, kind of where I think they're going. Like so, the key takeaways are this IoT thing. It's not going to be as bad as we're sort of making up to be. We had a dry run with all these mobile devices, and it's just at the end of the day going to be more of the same. And again, remember, we can take this in steps. Let the business be the business. We're going to support them in the same way that we always have supported them with any applications, and we don't have to go nuts, you know, off the bat. We can look for simple data collection and simple alerts and go from there. So with that, I don't know, see you in 18 months? I don't know what's next. Anyway, thank you so much.